Today we're going to talk about lines in the coordinate plane, section 3.6. Last section of chapter 3, again talking about coordinate geometry, and we're talking about lines in the coordinate plane. So a lot of algebra review really today. There's a lot of good algebra review here. Vocabulary. First thing we're talking about is point-slope form. Point-slope form, again, where's the name come from? Because to have point-slope form, you need a point and you need a slope. So point-slope form is this equation here. You'll want that equation written down. We're going to use that a lot. Y minus y1 equals m parentheses x minus x1, where m is the slope and x1, y1 is a point on the line. So again, I need a slope and I need a coordinate, and then we can write an equation of a line. So point-slope form is given to me when I know the point, I know the slope. Again, here's the equation. It's also over here on the poster. So if you look, it says point-slope formula. And it's on the front of the board, if you look up there. Point-slope form. Slope-intercept form. Slope-intercept form you should be able to recognize right away. Should have done that a lot in Algebra 1. Slope-intercept form is known when we know a slope and we know the y-intercept. Henceforth, why it's called slope-intercept form. The slope-intercept form of a linear equation is y equals mx plus b. Do we recognize that equation? You should recognize that, y equals mx plus b, where m is the slope and b is the y-intercept. So m is the slope, b is the y-intercept. That form is also over here on the poster. If you look right there, right above point-slope form, is y equals mx plus b. If you look all the way at the top, it actually gives it again. M equals slope, y equals mx plus b. See that? Lots of them over there. Algebra 1 review. All right. Typically, I use point-slope form a lot of times when I write equations. And we use point or slope-intercept form a lot of times when we graph equations. Okay, so point-slope form a lot of times where you start writing equations, we use that. It's a lot easier. Slope-intercept we use a lot of times when we graph. It's usually the easiest form to graph out of. Slope-intercept form is pretty straightforward to graph. So here's what this looks like today. We're going to identify some slope in y-intercept. So again, my y-intercept is always the b. It's also known as my constant. The y-intercept is always my constant. Does everybody know what a constant is? Does everybody know what a constant is? What's a constant, Simeon? Something that doesn't change. It has no variable. So a constant is a number with no variable. So it's not going to change. It's going to stay that number. Nice job. All right, slope. Slope is associated with my variable there. Okay, so slope is associated with the variable, typically my x there. We're going to write some equations today. So for example here, if I were to look at the point-slope form, well, I would identify my slope in there, and then I plug in my x and my y coordinates into that equation right there. And that's point-slope form. All right? So again, looking through some equations here. First thing we're going to talk about is writing an equation. Well, number 1 says write an equation of the line with a slope of 1/2 and y-intercept of 4. It gives me the slope and it gives me the y-intercept. What form am I going to use? I'm going to use slope-intercept. Okay? If it gives me slope and it gives me a y-intercept, I use slope-intercept. Use the names they give you. So what is slope-intercept then, Chris?
Y equals mx plus b.
Okay, y equals mx plus b. Now notice y and x are always y and x, so I'm going to substitute in my slope, and I'm going to substitute in my y-intercept. What's my slope here? Half. So I'm going to say y equals 1/2 x plus, what's my y-intercept? 4. Y equals 1/2 x plus 4. That's slope-intercept form. Okay, so if they give me slope and they give me y-intercept, I can straight plug that right in. 2, write an equation of the line with a slope of 3 and y-intercept of 5. Well, as I look at that, slope of 3, y-intercept of 5, I have a slope and I have the y-intercept, so I want to use slope-intercept. How would that be in slope-intercept form? What's my slope colon? So I say y equals 3x. What's my y-intercept colon? So y equals 3x plus 5. That's slope-intercept form right there. Number 3. Write an equation of the line with slope -2 and y-intercept -2. Well, how's that going to be now in my equation, Becca? Y equals negative 2x minus 2. Why are we saying minus 2 there, Becca? Since it's negative, right? Subtraction and negative are the same thing, so I'd say minus. So that's slope-intercept form. Again, when they give me slope and they give me y-intercept, I can just use that. Next, now I'm going to use that to graph. So I want to graph y equals 3x minus 1. Now, what form is that in? That is in what form? No, that is in. That is slope-intercept. This is slope-intercept. Slope-intercept is y equals mx plus b. Okay? So the first thing I need to do is I need to find my y-intercept. My y-intercept is always my what again? It's always my b, or my constant. So what is my y-intercept here, Spencer? Which one's my constant? Huh? Negative 1. So my y-intercept is negative 1. Who can tell me what that would be as a coordinate? What is my y-intercept as a coordinate? Look at maybe some Algebra 2 students that should know this. Callie? My coordinate there would be 0, negative 1. Okay, so when we say the coordinates here, I want to make sure you note that. If you look over here on the poster, again, it gives you that. Y-intercept, it gives me the coordinate. 0, whatever that y-intercept is. It's always going to be 0. Why? Because that's always, the y-intercept is always where x equals 0. Okay, so your coordinates, or your y-intercept is always going to be 0, your constant. Next, I want to find my slope. Well, what's my slope here going to be? Quinn, what's my slope? Yep. My y-intercept is negative 1. What's my slope? Okay, well, I'm helping you out here. My y-intercept is negative 1. What's my slope going to be? Huh? 3. Now, if I want to write a slope, remember slope is rise over run? So I'm going to write 3 over what? I'm going to say 3 over 1. So I have my slope here of 3 over 1. So again, slope is rise over run. So from my y-intercept, I'm going to go up 3 over 1. Up 3 over 1. And I keep going. So I get coordinates here, a coordinate there. I could also go down 3, left 1, and I get a coordinate here. So now I go through here, and there's the equation of my line. Again, the key is finding the y-intercept and finding the slope. Let's try another one here. Number 5. Y equals negative x minus 2. Again, that's in slope-intercept form. First thing I need to do is I need to identify my y-intercept. Clark, what's my y-intercept? Negative 2. Clark, as a coordinate, what would that be? That would be 0, negative 2. So I go to 0, negative 2. Start there. What's my slope going to be? Oh, I don't know. Katie, what's my slope going to be?
1, negative 1.
It's negative 1. So as a rise of a run, that'd be negative 1 over... Negative 1 over... 1. Because you can't... Negative 1 over 2 now, that makes it negative half. I don't want to change the number. I can always write a constant over 1. Does everybody understand that? I can write any number over 1 and I don't change the number at all. So now negative slope. Which way am I going to go for a negative slope? I'm going to go down 1 over 1. Down 1 over 1. So I get coordinates that look here. Now I can connect my dot and make my line. So there's the equation of that line. Alright? Next thing we're talking about. Now we're going to talk about writing equations in point-slope form. Can anybody guess why it's called point-slope form? You need a point and you need a slope. So in order to use point-slope form, I need a point and a slope. Point-slope form says y minus y1 equals m parentheses x minus x1. Alright? Now again, y and x here are always going to stay y and x. Those two don't change. Alright? What I'm going to do is I'm going to plug in my y coordinate, my x coordinate, and my slope. So this would look like y minus, what is my y coordinate here? 0 equals, what's my slope? Parentheses, x minus, what's my x coordinate? Boom, that's point slope form right there. Y minus 1, or y minus 0 equals 1, parentheses, x minus 0. So again, plugging that in. Number 7, same idea, we're going to use point slope form here. What's my y coordinate, Parker? 5. So I have my slope, and I have my point. So I'm going to say y minus 5 equals, what's my slope read? Parentheses, x. Now what's my x coordinate here, Becca? So how would I write that? Why would I say plus 1/2? Yeah, because it's a minus a negative. 2 negatives going to be a positive. So I'm going to say plus 1/2. Nice job. 8. Write the equation line that has a slope of 1/2 and the point 3, negative 2. Ty, what's my y coordinate there? Negative 2. So I'm going to start with y. Am I going to say minus a negative 2, or what should I say there? I should say plus 2. So y plus 2 equals, what's my slope, Caden?
1/2.
Parentheses, what's my x coordinate, Brock? My x coordinate? Isn't it positive 3? Right, Brock? Well, look there. Positive 3 or negative 3? Huh? Look at the coordinate. Is the coordinate positive or negative?
Positive.
So I'm going to say x minus 3 now.
Yeah, that's what I said.
No, I asked what the coordinate was.
Yeah, I said 3. And then I said negative
Okay.
3.
Okay. So now you said negative 3. What happens here on these problems now? Write an equation of the line in point slope form that passes through the points 2, 3, and negative 1, negative 5. In order to use point slope form, what do I need to have?
Slope.
I need slope. What am I given here, though? Can I find the slope?
Yup.
Yeah, what can I do to find the slope?
X1 or
y2 minus y1 over x2 minus x1. I'm going to have to find the slope here. So using the slope formula, I have to find the slope. So I'm going to say negative 5 minus 3 over negative 1 minus 2. What's negative 5 minus 3? Over negative 1 minus 2? Negative 3. What's negative 8 over negative 3 going to simplify to? Positive 8/3. Now I have my slope. And here's where students make their mistake. The equation says y minus y1 equals m parentheses x minus x1. Does everybody see how it's point slope? I need 1 point. The biggest mistake students make on a problem like this, they plug in both points. You only need 1. If you plug in both, there's no equation there. Okay, I need 1 point. Katie, which point would you like to use? So I'm going to use the coordinate 2, 3, and I'm going to plug that into point slope form. Katie, how would that look in point slope form?
Y minus 3 equals 2, or yeah, 2.
No, what's my slope?
8 over 3 parentheses x minus 2.
Nice job. Now, could I use the other point if I wanted to? Yes. How would that look then? Well, now my answer would say y plus 5 equals 8/3 parentheses x plus 1. It's the same equation either way. Okay. Number 10 here. I need to find the slope again. I'm given 2 coordinates. I need to find the slope. How would I find the slope here, Rennie? What would I have to do? How do I find the slope between 2 points? What do I use? What do I use, Bannister? I use the slope formula. y2 minus y1 over x2 minus x1. So I use slope formula here. So what would that be? Bannister, I'd say 3 minus 4 over 2 minus the negative 1. So it's really going to be 2 plus 1. What's 3 minus 4, Trent? What's 2 plus 1? I get a slope of negative 1/3. Now again, how many points do I use, Spencer? Which point do you want to use, Spence? So how would that look in point slope form now, Spence? Here's point slope form at the top. So what's my y coordinate? 3. So I'm going to say y minus 3 equals, what's my slope, Spencer? So I'm going to say negative 1/3 parentheses. What's my x coordinate, Spence? So x minus 2. Right there. Yeah, I could use the negative 1/4 if I wanted to. Now my answer would say 1 minus 4 equals negative 1/3 parentheses x plus 1. And I would still get the same answer. I get to choose which coordinate I use. Do not ever use both of them. You get to choose which one to use. Last thing. Okay, it says to graph this. What is the easiest form to graph out of, I said? Slope-intercept is the easiest form to graph out of. Slope-intercept, remember, is y equals mx plus b. Slope-intercept is by far the easiest one to graph out of. Okay? So when I do slope-intercept here, what am I solving for? Alright, so I want to get to slope-intercept form here. Y equals mx plus b. Slope-intercept form is just when it's solved for y. So I want to solve for y here. It's a two-step process to solve for y. I want to get y alone. Well, to do this, what do I need to do here first? Anytime you see a number outside of parentheses, what would you do?
Distribute.
So I distribute. Y minus 3 equals negative 2x minus 2. Now again, I want to get y alone, so what am I going to do? Add the 3 to the other side. And that gives me y equals negative 2x plus 1. Now that is in slope or slope-intercept form. You are going to do this a lot this year. You will want to get very good at changing that. Now it's in slope-intercept form, I can graph it. What's my y-intercept? Anybody, what's my y-intercept? 0, 1. So I'm going to go 0, 1. What's my slope? Negative 2. So from there, I'm going to go down 2 over 1, down 2 over 1. Okay. And now I draw my line. I get something that looks like that. Again, changing to slope-intercept form is a big thing. We're going to do that a lot. Let's try number 12 here. I want to graph it. In order to graph it, what form do I want? I want slope-intercept form. So y equals mx plus b. So y plus 1 equals 2 parentheses x plus 3. To change it to slope-intercept, it's a two-step process. What's the first step? So I distribute. Y plus 1 equals 2x plus 6. Now I need one more step. What am I going to do? Subtract the 1. Y equals 2x plus 5. Now it's in slope-intercept form. Now can I graph it?
Yep.
You bet. What's my y-intercept?
5.
0, 5. So that's just slightly off my graph here. And what's my slope? 2 or 2 over 1. So from there I'm going to go up 2 over 1, up 2 over 1. I kind of run out of room. So which way could I go?
Down.
I can go down to left 1. And that coordinate's there. Oops, not the last one. And now I can connect the dots, and I get my line. All right? And we're going to stop there. We'll pick up there tomorrow.